For today's lesson, we will begin working with ratios, and we have our 3 lesson objectives listed here at the beginning. So we're going to write ratios to compare 2 quantities, interpret ratios given in fraction form, and use a ratio to find what fraction one quantity is of another, or how many times as great one is as the other. And so the standards that will be addressed in this lesson are listed here. So we have 6 RP1 and 6 RP3D. So a ratio is a way to compare 2 quantities. And we've had some experience with the comparison when we wrote inequalities. And one way to do it is to write a sentence based on value. So in our first picture here, we have 7 orange cubes and we have 4 green cubes. So we could say that 7 is greater than 4, and that's comparing them based on their values. And in our second example, compare 5 centimeters and 9 centimeters. So we have a red rod that is 5 centimeters long and a blue rod that is 9 centimeters long. So we could say that 5 centimeters is shorter than 9 centimeters. So again, comparing the values, and from these you would write inequalities. Well, another way to compare is using a ratio. And when you use a ratio, you're just simply comparing. You're not saying one's larger than the other. You're not saying one is smaller than the other. You're just comparing how many of one you have with how many of another. So if we think of these as bags of orange cubes and bags with green cubes, and we do need to assume that each bag has an equal number of cubes. That's an assumption that we will always make when working with ratios, is that they will all have an even number. So one important thing to do is to make sure that you understand how to write the ratio. And so down here it says the ratio of the number of bags of orange cubes to the number of bags of green cubes. So since orange cubes are listed first, that would be the first term of your ratio. And to figure out how many orange cubes there are, we'll pretend that that's not written, as we would have to count. And if you look at our picture here, bags of orange cubes, we would have 1, 2, 3, 4, 5, 6, 7. And then since green cubes are listed second, we would list that number second. And again, we would need to count 1, 2, 3, 4. And so one way to write the ratio is with the colon, and that would say 7 to 4. Or you take out the colon, you put in the word 2, and you would have 7 to 4. And then the third way would be in the form of a fraction, 7 to 4. So an important piece of information is given in the statement here by this young man, and it's a statement that will come into play later in this chapter, and it's this very first sentence here. That the ratio does not give the actual number of cubes. And I like to think of the terms of the ratio to tell you how many sets. So you have 7 sets of orange cubes and 4 sets of green cubes. Now, you could have 1 cube in a set, you could have 5 cubes in a set, you could have 35 cubes in a set. But the important piece there is that it may not represent the actual number. When we're measuring, when we're writing a ratio for 2 quantities that we've measured, you can write the ratio and you do not have to label. So if we were comparing the red rod to the blue rod, and the red rod is 5, so that would be listed first, and the blue rod is 9, so that would be second. And you do not have to label. If you do label, that's okay, but you don't have to. When writing ratios for distance, or for measurements, it is important that they are in the same unit of measurement. So if we have 4 meters and 3 centimeters, we cannot write those because we cannot write a ratio for those because they have different units. So it's important to either put them both in centimeters or put them both in meters. So our young lady here knows that 1 meter is equal to 100 centimeters. So she converted the 4 meters into 400 centimeters and was able to write a ratio of 3 to 400. Two other conversions that will come in handy over the next few days would be 1 meter is equivalent to 1,000 millimeters, and 1 kilometer is equal to 1,000 meters. And with these, it won't always be meters, but it could be grams or liters, and you would just take out the word meter and put in liter or grams, depending on what it is you're measuring. If the two quantities you're given do not measure the same item, you cannot write a ratio. So 3 centimeters would measure distance, 4 kilograms measures weight or mass. Since they are not measuring the same thing, you cannot write the ratio. So here's our first two examples here. The ratio of the number of CDs to the number of CD sleeves is, and so on this one you'd have to count, and you would find that there are 3 CDs and there are 5 sleeves. So your ratio is 3 to 5. And you can write it any of those 3 ways. Our second one here, Mrs. Carter buys 4 bags of apples and 7 bags of oranges. Each bag has an equal number of fruits. And we want the ratio of the number of apples to the number of oranges. So there would be 4 apples to 7 oranges. So our ratio is 4 to 7. For question number 3, Desiree has a cat that weighs 12 pounds and a dog that weighs 13 pounds. And so for part A, we want the ratio of the weight of the cat to the weight of the dog. So that would be 12 to 13. And for part B, the ratio of the weight of the dog to the weight of the cat is 13 to 12. And it is important to take note of which item is listed first and make sure that that value for that item is listed first. And since the cat is listed first in part A, you put the cat's weight first and the dog's weight second. And in part B, the dog's weight is listed first, so you put the dog's weight first and the cat's weight second. For 4, 5, and 6 here, we're simply writing yes or no. So for number 4, we have 6 kilograms and 84 kilograms. And yes, of course, that can be written as a ratio. They're both in kilograms. For number 5, 72 feet and 2 yards. Yes, those can be written as ratios because both of those measure distance. And number 6, 3 ounces and 30 inches. No, you cannot write those as a ratio because ounces measures weight and inches measures distance or length. For number 7, 8, and 9, we need to write the ratios based on our metric measurements here. So for number 7, I see I have centimeters and meters. So I could look back in my notes and I could find the conversion of 1 meter is 100 centimeters. Well, I see that I have 2 meters here. So if 1 meter is 100 centimeters, 2 meters would then be 200 centimeters. So my ratio is 13 to 200. And I picked that because it's easier to go from 1 to 2 than it is to go from 100 to 13. So for number 8, I have kilograms and grams. Now if you flip back in your notes, you won't find kilograms, but you'll find kilometers. It's the same conversion. So 1 kilogram is equal to 1,000 grams. So is it easier to go from 1 to 5, or is it easier to go from 1,000 to 13? Well, it's easier to go from 1 to 5. So if 1 kilogram is 1,000 grams, 5 kilograms would be 5,000 grams. So therefore your ratio is 5,000 to 13. And then finally, we have milliliters and liters. Well, 1 liter is equal to 1,000 milliliters. You just take out the meters that we did previously and put liters in. And is it easier to go from 1 to 7 or 1,000 to 9? Well, it's easier to go from 1 to 7. So if 1 liter is 1,000 milliliters, 7 liters would be 7,000 milliliters. So our ratio would be 9 to 7,000. So in a situation where we have 55 adults and 32 children at a party, we want to find the ratio of the number of adults to the number of children at the party. So number of adults is listed first, so that would go first, and our ratio would be 55 to 32. And again, you can write it any one of these three ways. And this is called a part-part model. And the reason it's called a part-part model is neither of those terms represents the total number of people at the party. But if we slide down and we look at example B, we want to find the ratio of the number of children to the total number of people at the party. Well, to find the total number of people at the party, we should take the number of adults and the number of kids, add those together, and we would get 87. So the number of children is 32, so it would be 32 to 87, 32 to 87, or 32 to 87. And this is referred to as a part whole because 87 does represent everyone at the party. And so that would be very similar to what you would do for a fraction. Just got a couple more here, and then we'll be done with the day one portion of the lesson. So John, great name there, keeps 17 angelfish and 24 guppies, which is actually almost true. We do have some guppies at home. No angelfish, though. So we want to find the ratio of the number of angelfish to the number of guppies. Well, since angelfish is listed first, we'll start with 17. And since the guppies are listed second, we'll do 24. And then for part B, find the ratio of the number of guppies to the total number of fish. Well, guppies would be 24 to the total number of fish. Well, if I have 24 guppies and 17 angelfish, I add those together to get 41. So my ratio would be 24 to 41. And then our final two examples for today. Alex has a string 72 centimeters long. He cuts it into two pieces. The length of the shorter piece is 31 centimeters. What is the ratio of the length of the longer piece to the total length of string? Well, I know the total length of string is 72 because that's what it says. Alex has a string 72 centimeters long. That's the length of the string. But what I don't have is the length of the longer piece. So I take the string, I take the shorter piece, and since it says I cut, I need to subtract. That would give me 41. So my ratio here is 41 to 72. And then our final example for today is number 12 here. The total amount of money Pamela and Rachel saved in a week was $45. Pamela saved $13. So I want to find the amount of money Rachel saved. Well, if they saved a total of 45 and Pamela saved 13, I need to subtract, and I get $32. And then for part B, find the ratio of the total amount of money Pamela and Rachel saved to the amount of money Rachel saved. Well, the total amount was 45, and Rachel saved 32. So 45 to 32 would be our ratio for number 12, part B. And that is today's lesson. As always, I hope this helped.